Okay, questions related to this electricity and chemistry. Okay, the first question, which reaction could take place at anode during electrolysis? Anode is a positive terminal. So as it's a positive terminal, the negative ions, the ions which are negative in charge are attracted towards anode. So which reaction can occur? Positive at anode, the negative ions are attracted towards the anode. So which equation should be correct?
D.
Anode is a positive terminal, and positive terminal always attract the negative ions. So hydroxide is negative ion and chloride is negative ion, so they are attracted towards the anode. So A is the right answer. Everyone should participate. This is for your to check your understanding. Even your answer is wrong, that's not an issue, so that you will learn from your mistakes. So try to answer these questions. This is to check your understanding of the topic. Okay. The diagram shows the electrolysis of molten zinc chloride. So molten zinc chloride means there is no water. So for a molten zinc chloride, what are the ions present? We have zinc ions and we have chloride ion. Zinc ions are attracted towards electrode Y or cathode. So zinc ions will take 2 electrons and change into zinc atom. And chloride ions are attracted towards the positive terminal anode. They will lose 1 electron, change to chlorine atom. When 2 chloride ions are there, they will lose 2 electrons and it will form chlorine gas. About this equation, because in some, like if it is written 2Cl minus 2E gives Cl2. If this is minus 2E, if I move the electron other side, the same equation can be written as 2Cl minus gives Cl2 plus 2E. These two equations are same. There is no difference between the two equations. So what happened? Which statement is correct? And what is this change? When something is lose electron, we call oxidation is a loss of electron and reduction is a gain of electron. Oxidation occur at electrode X. So oxidation happen at electrode X and the equation is, so A is the right answer. Oxidation is a loss of electron where reduction is a gain of electron. Oxidation occur at Y. Actually, oxidation does not occur at Y, so this is wrong. Reduction occur at X. Reduction does not occur at X, so this is wrong. Reduction occur at Y, and the equation is given wrong. That's why this is not correct as well. The diagram shows a method used to copper plate a pen. So pen is there and we are copper plating. Which equation represent the reaction at cathode? So basically what happened? The copper ions, because it's a copper 2 sulfate, so copper ions are attracted towards the pan and the copper atom will go inside the solution as a copper ion. So which equation represent the copper ion? Will gain electron and they change into copper atom. Yeah, A is the right answer. Everyone should participate in this. It's for your understanding. Even you answer it's wrong, that's not an issue. The main thing is you should try to attempt or answer the question. Which apparatus could be used to electroplate an iron nail with copper? Which one is the correct answer?
C.
We want copper plating.
Oh, A. Copper plating. A.
Because in this case, we have a solution of iron, but we need a copper plating. So if we need a copper plating, copper ions, which are there in the electrolyte, attracted towards the cathode, and copper atom will go inside the solution as a copper ion. There's a chemical cell topic, that is the last topic of this chapter. I will discuss after this assignment. Aqueous copper 2 sulfate is electrolyzed using a carbon electrode. So what we are using now, we are using carbon electrodes. So better you draw the figure so that you have a better understanding of the question. You have aqueous copper sulfate, so means it contains copper ion, it contains sulfate ion, it contains aqueous is there, so it contains hydrogen ion and hydroxide ion. And this is made up of carbon or graphite. So unreactive electrodes are there, or inert electrode we also call them. So in this case, for positive ion, less reactive will move. You're electrolyzing using a carbon. So copper ions are less reactive, so they're attracted towards cathode. So copper ions, as they are attracted towards the cathode, copper plus 2 ion, they will change into copper atom. And what will happen at anode? Sulfate, nitrates, and carbonate does not move, so you are left with hydroxide. Hydroxide will move, and whenever hydroxide ions move there, they will lose 4 electrons, give oxygen and water. So oxygen is observed at anode, and copper is observed at cathode. So what is the right answer? So oxygen and copper, so C is the right answer. The diagram shows a circuit used to electrolyze aqueous copper to sulfate. Which arrow indicate the movement of copper ions in the electrolyte and electrons in the external circuit? This is a positive terminal of the battery. This is a negative terminal of the battery. For electrons, electron always come out from the negative terminal and move towards the positive. So which arrow is representing the movement of electron? Movement of electron is represented by third one. And movement of the copper ions are positive ions, so they are attracted towards the cathode. So C is the right answer. Within the electrolyte, the copper ions are attracted, and in the wire, the electrons are moving. Concentrated aqueous copper to chloride is electrolyzed using a copper electrodes. So we are using copper electrodes. So what happened in this case, the copper ions from the electrolyte will move towards the cathode, and copper atom will go inside the solution as a copper ion. What will happen to size of cathode?
B.
Size of cathode will increase and size of anode will decrease. So that's why B is the right answer. This is a structure question. Electroplating steel object with silver involves 3 steps. Like we have a steel object and we want the plating of this steel object. First, a coating of a copper is applied. So first we coat it with copper. Then a coating of a nickel is applied, and then the coating of silver is applied. So we have 3 coating on this steel object. The diagram of apparatus used for step 1 is shown. The first step is plating it with copper. So how we are doing? Copper 2 sulfate electrolyte is there. So copper ions which are within the electrolytes are attracted towards the steel, and copper atom from the anode will go inside the solution as a copper ion. The chemical process take place on the surface of object, because what happened, the copper ions, as they will move towards the object, the copper ion will take 2 electrons and it change into copper atom. Explain whether this process is oxidation or reduction. What is this process called?
Reduction.
Reduction. And why it is reduction? Because it is a gain of
Gaining.
electron. Explain why the concentration of the copper ion in the electrolyte remain constant throughout step 1. Means the amount of copper ion within the electrolyte does not change. So what is the reason for that?
Because anode gives the electrolyte, the copper
So,
atoms.
yeah, so how you'll explain this, you will mention copper ion move towards the cathode, or the amount of copper ion discharge at cathode is same as amount of copper ion enter from anode. So when one copper ion is going out from the electrolyte, at the same time one copper atom enter and change into copper atom change into copper ion and enter the electrolyte. So the answer for this, you have to mention that copper ion from electrolyte move towards or discharge at cathode is same as copper atom change to copper ion and enter electrolyte from anode. So 1 mark is for mentioning the change at cathode and 1 mark is for mentioning the change at anode. Give 2 changes which you would need in order to coat a nickel. Now what you want, instead of copper plating, you need a nickel plating. What I should do? Instead of copper, I want a layer of nickel on this. What I should do? What 2
Change
changes? Yes.
and anode.
What
Replace the
changes?
anode with a nickel
Yes.
material
Good.
one, and also replace the electrolyte with a nickel
Replace
salt.
nickel salt. So basically the anode, because whenever we want a plating, we want anode and electrolyte should contain the same less reactive metal. And Afif, your question was at the end of session, you asked a question that this can only be done if you have an aqueous electrolyte. This can only be done for less reactive metals than hydrogen. Is it clear, the concept of electrolysis?
Yes, sir.
Then the last topic of this chapter is a chemical cell or voltaic cell or galvanic cell, all having a same meaning. So what is a chemical cell, voltaic cell or a galvanic cell? Actually, this cell produce electricity or produce a current by chemical reaction. So due to a chemical reaction, it produces a current. When a chemical reaction produces a current, we call that cell as a voltaic cell or a galvanic cell or a chemical cell. Like example, the batteries you are using for a remote control. So these batteries are also galvanic cell or a chemical cell. So if I connect a lamp with this battery, what I will observe? I'll observe a lamp light up. So why this lamp light up? Because there is a movement of the charges or flow of the electric current. That's why the lamp light up. So you will study the basic concept of a galvanic or a voltaic cell, not in detail, but a basic concept of a galvanic cell. So what is the basic concept of a galvanic cell? A galvanic cell consists of electrolyte, a solution or electrolyte, and normally acids are used, but it can be any salt as well, acid or salt solution. And we use two electrodes, but these electrodes, two plates, and these plates are made up of different metal. And we connect a lamp or a bulb or a meter, we call that as a voltmeter. Here I connect a lamp. So it consists of two electrodes made up of different metals and electrolyte. How it works, the working, because metals, when anything consists of metal, how the metal react, the metal have a tendency to lose electrons. All the metals have tendency to lose electron. More reactive metal tend to lose electron fast. Less reactive metal take time to lose electron. They will also lose, but the rate at which the more reactive metal can lose electron is much higher as compared to less reactive metal. So example, if on the left hand side this is made up of zinc, on the right hand side it is made up of copper. So zinc and copper are two metals and they have difference in the reactivity. And the electrolyte normally are acids, as like hydrochloric acid or sulfuric acid. So example, if a acid, sulfuric acid is there, so hydrogen ion, sulfate ion, and acids are also aqueous, so it contains hydrogen ion and hydroxide ion. Is it okay now? My voice is audible? Okay, so it consists of two metals which are having difference in the reactivity. One is zinc, another one is copper. Which is more reactive metal here, zinc or copper?
Zinc.
So zinc is more reactive metal, so means zinc will react first. So what happened, the more reactive metal will lose electrons first and change into ion. So the more reactive metal will lose electron first and it will change into ion. So what will happen? The zinc atom, which is more reactive, will lose electron first and it will change into zinc ion. So what will happen to the electron which are lost by the zinc? So the electrons lost by the more reactive metal travel through the wire and reach less reactive metal surface. So as what happened, the zinc atom will go inside the solution as a zinc ion. What happened to electron? Electron cannot travel within the electrolyte. So these electrons will travel through the wires. So as these electrons will move, what we will observe? We will observe that the lamp light up. So this lamp start to work or it light up because the electron actually travel from more reactive metal surface to less reactive metal surface. So this will have now more electrons. Then what happened? The electrons at less reactive metal surface attract positive ions less reactive positive ion from electrolyte. So in this case, what happened? Which is less reactive positive ion? Hydrogen is less reactive positive ion. So hydrogen is attracted towards the electron. So what will be the equation for this plate? The hydrogen ions are attracted, they take electron, change to hydrogen atom. But when two hydrogen ions are there, they will take two electron and it will form hydrogen gas. So what we will observe? We will observe bubbles here at the less reactive electrode or metal plate. And what happened? The zinc atom is going inside the solution as a zinc ion. So equation is zinc atom will go inside the solution as a zinc ion by loss of two electron. So this is how the electrolytic cell works. So what happened in this? The electrolytic cell consists of two metal plates, but the two metal plates are made up of two different metals. It should consist of two different metals. Metal should be more reactive than the other. So when one metal is more reactive than the other, so which one will lose electron first? The metal which is more reactive will lose electron first. So in this case, zinc is more reactive. So zinc atom will go inside the solution as a zinc ion. So zinc atom will go inside the solution as a zinc ion. Electrons which are lost by the zinc will travel through the wire and it will stop at the less reactive plate because electrons cannot move within the electrolyte. Electron can only move through the wires. The electrons which are more at the less reactive electrode, these electrons are negative, so they will attract the positive ion from the electrolyte. So as they attract the less reactive positive ion from the electrolyte, the less reactive positive ion will discharge at the plate. So this is how a chemical reaction is producing a current. So we call that as a chemical cell or a voltaic cell or a galvanic cell. Is it clear, the idea of a chemical cell? Take the screenshot. I will give application of this chemical cell as well. The less reactive here, this is anode and cathode is there, but we don't specify. The more reactive is called a negative plate. Why we call a negative plate? Because in the beginning there are more electrons. That's why we call negative plate. An electron travel. So as the electron are moving towards the less reactive plate, so less reactive plate is known as positive plate. Instead of saying anode and cathode, it's better you use the term negative plate and positive plate. The more reactive metal is always termed as the positive plate, and the less reactive metal is always termed as a, sorry, the more reactive metal termed as a negative plate, and the less reactive metal is termed as a positive plate. Another example where we can use this, the chemical cell can be used to find reactivity of different metals. So with respect to movement of electron in the beginning, when you compare, in the beginning, this plate was not having an extra electron. This plate was having extra electron. That's why in the beginning, this plate is negative, and the electron move from this plate to another. We call that as positive plate. So chemical cell can be used to find the reactivity of different metals. Example, we have electrolyte, and it consists of two different metal plates. And there is a lamp. Two metals are there, X and Y. And the electron is moving from, this is a movement of electron from Y to X. Which is more reactive? Which is more reactive metal here, X or Y? So Y is more reactive because electron always move from the more reactive plate to less reactive. So this shows the Y is more reactive than X. If there's another cell, which consists of Y and another element Z. So you have Y and you have Z, and the electron is moving from Z to Y. Which is more reactive here?
Z.
So electron is moving from Z to Y. So in this case, Z is more reactive. If I say set up a reactivity series between X, Y, and Z, so which is the most reactive? So if we want to set up a reactivity series, we want to identify the more reactive and the less reactive in this series. So Z is more reactive, then followed by Y, and at the last, X. So we set up the reactivity series. So using a chemical cell, we can identify the reactivity of different metals, or we can set up the reactivity series. Is it clear? Take the screenshot. I'll give more examples related to chemical cell. Yes. Any question?
Sir, when we make aqueous concentrated HCl, what's gonna form in the electrolyte?
Can you repeat your question? I just did not hear. If you was using,
Aqueous concentrated HCl.
okay, as an electrolysis
Yeah.
using the carbon electrodes. So example, you have aqueous concentrated HCl. So positive and negative, the solution contain hydrogen ion, chloride ion, it contains hydrogen ion and hydroxide ion. Anode and cathode are inerts, and this is aqueous concentrated HCl. So if we say HCl, it's concentrated, so more hydrogen ion and chloride ions are there. And if it the water, because it's aqueous, so water is also there, but small amount because it is concentrated. For positive ion, the criteria is the reactivity, but in this case, you have the identical positive ion, so it will not make difference. Any hydrogen ion can move. So as hydrogen ion will move towards cathode, hydrogen ions will take electron, change into hydrogen gas, so you will observe bubbles. For negative ion, you check the amount. So when you check the amount, chloride ion is more, so chloride ion will discharge at anode. So chloride ion, when two chloride ions are there, they will lose two electrons, change to chlorine gas. So you will also observe bubbles. So what you're left with, you're left with more hydrogen and hydroxide ion. So you're left with more water. So what we'll say, what will happen to electrolyte when you're left with more water, you will say the electrolyte will become dilute HCl. Why we are saying dilute HCl? Because the term, when you have more water in the electrolyte, you call that as a dilute HCl. So it will become dilute hydrochloric acid. Is it clear?
Sir, all the hydrogen ions and the chloride ions are being reduced and oxidized in the cathode.
No, actually, yeah, but actually, if what happened, it's a cyclic process. Because what happened, once you will have more, it will become dilute hydrochloric acid, then OH start to discharge. Then again, it become concentrated hydrochloric acid, Cl start to discharge. So it's a cyclic process in which both in the beginning, chloride ions are moving, but when sufficient amount of water is there, then hydroxide ion will discharge. When sufficient amount of chloride will be there, then chloride ion will discharge. So it's a cyclic process. That's why I did not say the electrolyte will become water. It will become dilute hydrochloric acid. Is it clear?
Yes, sir.
So basically what happened, you have H ion, you have chloride ion. So chloride ion and H ion are removed, but not completely removed. Why not completely removed? Because once the solution will have more water, then hydroxide ions start to discharge. So that moment it will become concentrated again. So it will change, like from first dilute hydrochloric acid, then concentrated, then dilute, and it will happen until all of the ions are removed from the electrolyte. But in the beginning, when you compare the start of the process, because you're left with more water, that's why we say it will be dilute hydrochloric acid. Is it clear? The question.
Yes, sir.
So for a chemical cell, sometime the voltage is given. What is the voltage? Voltage means how much energy carried by each charge. So how much energy is carried by the charge, that's called a voltage. And higher voltage means greater difference in reactivity of two metals. So when the metals have greater difference in their reactivity, it will produce a higher voltage. Example, you have two electrodes. I'm not drawing the electrolytic cell, I'm just drawing the electrode for a chemical cell. to explain the idea. Instead of having a lamp, you have a voltmeter. Voltmeter symbol, circle with V, that's called a voltmeter. And you have three metals, X, Y, and Z. X, Y, X, Z. And the movement of electron is from Y to X and the movement of electron is from Z to X. This is X here. Which is more reactive here between X and Y? Which is more reactive? Which metal Y is more reactive? So I circle Y. Which is more reactive between X and Z?
Z.
Z is more reactive. But I cannot set up the reactivity here. Why I cannot set up the reactivity? Because I don't know whether Y is more reactive or Y is above X or sorry, Y is above Z or Z is above Y, because there is no comparison in this question between Y and Z. But I have another thing in the question. They give me voltage. They mention this is producing 2 volts and this one is producing 3 volts. So what does it mean? If it is producing a high volt, it means greater difference in the reactivity. So example, if I say Y and Z or X and Y, it was producing 2 volts. So I have X and I have Y, and how much voltage it produced? It produced 2 volts. You can just draw a line of 2 centimeters to understand this concept. Higher voltage means greater difference in the reactivity. But between X and Z, it is producing a voltage of 3 volt. So means from X to Z, there is a higher voltage. And how much voltage it produces? It produces 3 volt. So what is the reactivity? The reactivity is Z, Y, and X. So higher voltage produced by the two metals, two electrode, it means they have a greater difference in the reactivity. Smaller voltage produced means small difference in the reactivity. But if a question is what is the voltage if I use two electrode, one made up of Y, another one is made up of Z, what will be the voltage produced? Yeah, what will be the voltage produced? It will produce 1 volt, because the difference between Y and Z is, if this total